Okay, guys, we're going to talk today about weather versus climate. We've kind of already talked about it a little bit, but now we're going to go through the PowerPoint. So make sure you have your science notebook with you.
Could it be a nicer day for a hike? I don't know what you're bringing all that stuff for. Hey, you never know when the weather's gonna change. Gotta be prepared. RJ, it's like the sunniest day so far this summer. No way it's gonna rain. Right now it's sunny, but I'm telling you, weather is the condition of the outside air or atmosphere at a particular time and place. It can change quickly. Ever hear of braving the elements?
We've already recorded that.
I think so. Well, it means the elements of weather. Air temperature, air pressure, humidity, wind, clouds and fog, and precipitation like rain, snow, and hail.
Okay, if you were to take a minute and record elements of weather, air temperature, air pressure, humidity, wind, clouds and fog, and precipitation. This is important because when we sit down and we start really talking about weather and the aspects, air pressure is going to be a huge aspect of how we measure the weather and how we work with it. So take a moment and record elements of weather, air temperature, air pressure, humidity, precipitation, clouds, and fog. And of course, wind.
Those are all elements of weather. RJ, I really don't think the weather is going to change right now. Oh yeah? I'm willing to bet you that 2 elements of weather are about to change as we hike up this hill. Ha! I'll take that bet. What's going to change in 5 minutes? How about temperature and air pressure? Even though it's sunny, the temperature of the air can still change. As we hike up the hill, it's going to get cooler because we'll be at a higher altitude or elevation. The higher we go, the cooler the air is, and the lower the air pressure. How much cooler can it get? Well, this hill isn't very high, so it won't get much colder. But if we were hiking something like Mount Everest, we'd be talking about serious freezing temperatures. Whoa, so the higher we climb, the colder the air temperature? Yep, and as we climb, it's going to get windier too. Cool air is heavier than warmer air, and it sinks. As it sinks, it gets warmer. Warm air rises back up again. When air sinks and rises like that, it causes winds. The higher we hike, the cooler and heavier the air is, and the faster it sinks. And the faster air sinks, the faster the wind blows. You got it. So it gets a little cold and my hair gets messed up. I can handle it. Okay. Then what if it rains? Rain? The climate is very nice today. Sam, climate has to do with the usual kind of weather in a certain place over time, not on a particular day. Check it out. There are different climate zones all over the world. The main differences between...
And you'll notice that you'll see these colors. And of course, the closer to the poles that you are, of course, the colder it is, or even the cold polars here. You'll notice that Africa is usually... for the most part, either humid warm or humid temperate. It doesn't usually get the purple or the blue. Now, you notice that where I'm humid temperate right here. When we go to talk about biomes in a little bit, in the next couple of weeks and months, you'll find out what biome we are and how it really plays in with our climate.
Each climate zone are precipitation and temperature. And those 2 things make the plant and animal life of each climate different. Climate is the overall weather pattern of those 2 elements in a certain area over time. So weather changes day to day, but climate has to do with the big picture, and the weather today is picture perfect. It is a warm, sunny day, but this heat means more moisture is being evaporated into the warm air. As that warm air rises higher, it cools, and that moisture turns back into droplets of water. When that happens, clouds form.
Remember, water cycle, guys.
Clouds can't hurt us. They're big, fluffy puffs of air. They're big, fluffy puffs of cold air ready to burst with rain. You seem to know a lot about the weather today, RJ. Did you watch the weather on the news or something? I always check the weather. That weather guy is called a meteorologist, and his job is really important. Meteorologists...
Okay, so take a moment and write the job title of meteorologist. Is a person who studies weather patterns and attempt to predict the future weather. So if you'll take a moment and record meteorologist.
study weather patterns to try to predict future weather. Who needs a meteorologist when I have you? I think I felt a drop. Did not. Come on, you have to be kidding. What'd I tell you? You told me all right. Weather describes the condition of the outside air of a place at a certain time, and at this certain time, it's raining. But like you said, many factors affect changes in weather. Weather changes every day, and climate describes the weather of a place over time. Climate zones explain weather patterns and plant and animal life of particular areas. And I think we should move to a climate where it never rains. Oh, come on. A little rain never hurt anybody. Lucky for you, I brought an extra raincoat. Thanks. I guess we can still hike, thanks to all your rain gear. But how am I supposed to paint? Watercolor?
So let's go to the test yourself. What is the weather of a certain area over a long period of time? Is it the climate zone, the moisture, the climate, or the element? Take a minute. Certain period of time, long period of time. Should choose climate. What is the condition of outside air at a certain time and place? Certain time, certain place. Is it the climate zone, the weather, the climate, or the element? Should be weather. What are air pressures, humidity, clouds, and temperatures called? Elevation pressure, elementary aspects, elements of weather, or elements of climate? Think about it. We just took notes earlier. And what did we record it as? We recorded it as elements of weather. What are climate zones? Areas that are divided by precipitation and temperature. Different levels of hills and mountains divided by altitude. Weather at different times of day and at different months. Or areas that are divided mainly by clouds and time. Climate. Think about what we look at when we look at climate. What are the aspects that we're looking at? What is a person who studies a pattern in an attempt to predict weather? Climatologist, seismologist, an astronomer, or meteorologist. This one's easy, guys. Meteorology. What forms when moisture evaporates into the air and then cools? Climate, a cloud, wind, or altitude? What forms when moisture evaporates into the air? Think about the water cycle. It's evaporating. It's going to form a what? Cloud. What causes wind on top of mountains, hills and mountains? Cool air rising while hot air sinks. Cool air and hot air hitting each other. Hot air rising while cool air sinks. Or cool air and rain clouds. Well, you know it's that pattern. But think about what's rising and what's sinking. So, Is it hot air rising or cool air rising? I think it's hot air rising. Let's see if we're right. Yay! Sorry, guys. Okay, so now our favorite crash can lady. You probably will need your science notebook.
If you're like me, you know what your perfect day looks like, weather-wise. Sunny, rainy, snowy, whatever. Personally, I love it when it's cool and cloudy, like just cold enough to wear a sweater. You probably know that weather has something to do with how hot or cold it is outside. But really, there's a lot more to it than just temperature. So grab your sunglasses, your rain boots, and your most colorful scarf, because today, we're talking weather. Let's start with a big and pretty basic question. What exactly is weather? Well, weather is the condition of the air, or the atmosphere, on our planet.
Which we've already recorded.
The thing is, even though there's only one atmosphere on Earth, the weather isn't the same all over the world. There are many different factors that can change the atmosphere in a certain area, and together they determine what the weather is like from one minute and from one place to the next. These factors include temperature, humidity, wind speed and direction, and lots of other things. But when you're talking about the overall weather patterns from a certain region of the world, you're talking about the area's climate. Weather is the minute-by-minute changes in the atmosphere. Climate is what the weather is like over a long period of time in a specific area. Now, the weather is constantly changing all the time, every day. Think of the weather as being like that one friend of yours who can never make up their mind about what movie they want to see or what restaurant they want to go to. Just because it's beautiful and sunny outside when you wake up, that doesn't mean you won't need an umbrella before the day's over. And raining is just one of the things that weather can do. Rain, of course, is just a form of precipitation, or water that falls from the sky. It happens when droplets of water in the clouds, or sometimes ice crystals, get heavy enough and fall to the ground. If they're crystals, the warm air near the ground will melt them as they fall, forming liquid raindrops. But do you want to build a snowman? Another common form of precipitation is snow. Snow is just ice crystals that don't melt into liquid water as they fall. Another snow-like form of precipitation is sleet. It's what happens when ice crystals fall toward the ground, partly melt, and then refreeze again. But other kinds of weather can be way more severe, and the most common kind of extreme weather is a form I'm sure you're familiar with. Thunderstorms. A thunderstorm can happen when strong winds make drops of water and pieces of ice collide and break apart inside a storm. This causes electrical energy to build up, which creates a little something called lightning. But all of this rain and snow and sleet I've been talking about, that's all just weather. And while weather can change in a few hours, a region's climate takes hundreds, thousands, even millions of years to change. So how can we better understand the difference between weather and climate? How about we send Cartoon Sabrina on a little imaginary trip for a month? Okay, here she is at her destination, Yuma, Arizona. Let's pretend it's the 5th of the month. On this particular day where Cartoon Sabrina is, it's warm but very cloudy and the light rain has been falling on her, sorry me, all day. Since clouds and rain are what the atmosphere has to offer on this particular spot at this moment, and they can go away at any minute, those conditions are, yep, the weather. Now let's fast forward to the 10th of the month. Hello, sun. Looks like Tiny Me won't be needing an umbrella today. How about the 15th? More sun. The 20th? Still sunny. The 25th? You guessed it. Sunny with a chance of, well, sunny. And finally, on the 30th, the sun's still shining. Little Sabrina, I hope you packed your sunscreen. So what does this quick time lapse of a month in Yuma tell us? It tells us that Yuma, Arizona is a pretty sunny place. In fact, on most days, it's one of the sunniest cities on the whole planet. So the city's weather patterns existed before Mini-Me arrived and will continue after she leaves. In that case, you could say that Yuma has a sunny climate, even if its weather on a certain given day happens to be rainy. Now you know that weather is much more than just temperature. It's the condition of our planet's atmosphere, and it's constantly changing. You also know that weather and climate are not the same thing. But I saved the extreme stuff for last. The severe weather stuff, that is. You'll have to tune in next time to learn more about tornadoes, hurricanes, and blizzards.
Okay. So let's look at this picture here. Climate versus weather. It'll probably hit 90. I'd better take a lot of water. So August 20th, he's looking. And weather is, it's 90. I'm glad I brought lots of water. So this is the actual moment things are happening. And this is a prediction of what the average is going to be. So weather is the state of the atmosphere at any given time and place. So if you're looking at this is from 2011, of course. And I like looking at it and going, it's February. And the north is in the 50s, which is really, really warm for that time of the year for them. Where we are in about the 70s, which is still quite warm for February. However, we've been known to get warm weather starting in February and really doesn't end until October. However, here is the day-by-day forecast that meteorologists predict. And what we're going to do after all of our videos, each day we're going to be starting a calendar, our weather calendar, and a weather forecast in our own little notebooks here, in which I'll explain a little bit later. That you're going to record today's temperature, the average rainfall, the average. We're going to look at all of that, and I usually like to pick 2 different places. And I pick Fayetteville, and then I'll pick another place. And it's usually not in the United States because their temperatures will be completely different than ours. So we'll probably pick like Australia. Okay, so discuss in your group. What's the weather like today? So you can look here. This is from 2007, of course. If you'll take a minute and just partner talk with the person sitting next to you, think about where we are right now. We're close enough to Raleigh. What are you seeing on this map? And then take a minute and discuss. This was March 13th, 2007. So if y'all take a moment and discuss that temperature for that time frame. To me, March 13th, 2007, 80 degrees is quite warm for March. It's even quite warm to have 63 up here in Baltimore in March. So, but once again, this was over 10 years ago. The weather has drastically started to change. Climate change has really affected us. We are going to fill this out. Don't worry about this right now, because we will be talking about that in the next either video or when I come back. So we know that what affects weather. We know that the temperature, the air pressure, the low pressure, the wind, the humidity, all affect what weather we are seeing right now. As you can see, Miss Hines in a turtleneck here in Pennsylvania. It's cold here. So the air pressure, the jet stream that's coming down has affected us. The humidity, we have really low humidity right now. It's not raining out right now either. So, but you can look in Salt Lake here, and you can see this color change right here. It's cooler, so they are going to start seeing precipitation. The higher the humidity, or the lower the humidity, sometimes you will see more weather. Up here, they're in the negatives. Look right here at the very top here of Montana, -7. And this is in February. So you can see that the jet stream, which we haven't talked about yet, you can see that the jet stream is this blue, basically this blue line. And when we talk about the jet stream, this is actually a really good picture to show you where the jet stream, the difference between the high pressure and the low pressure come to meet. And that's this right here in between the yellow and the blue. That's where the jet stream will fall into place. So we'll talk about that in the next couple days. Of course, temperature affects your weather. Your moisture, humidity. If it's dry, you have less humidity. Your wind. Look at that sailboat. Look at that. Woo. Don't know if I would want to be out in that today. Your air pressure. So the bottle was sealed at 1,400 feet, which was higher up. Then we moved it to 9,000 feet, and it was increased because the air pressure has increased. So just as simple as taking a water bottle, and the pressure of the water bottle from changing from the humidities has really changed. If you take a water bottle up into an airplane, you're not going to see this because your plane is cabin pressurized. It's cabin pressure. So you're not going to see the crushing. But if I were to take that bottle outside, I would see the crushing because of the air pressures changed drastically from when I boarded that plane. Okay. Climate is the average weather in a particular part of the world at a different time of the year. Each part of the world is going to have a different climate. We have a different climate than Arizona. We have a different climate than Alaska, Brazil, or Antarctica. All our climates are going to be different based on the region we live in and the tilt of the axis and the rotation and the revolutions that we see. So that was the whole point of going over the revolutions and rotations ahead of time so that you could see how this really will affect our climate. The Earth's tilt on the axis. Part of the Earth's points are more directly towards the sun than other parts, and therefore they experience more warmth. Earth's equator receives more warmth. North and South poles are the furthest from the sun, so that's why they are cold. It's like self-explanatory. Altitude. The height of the land from sea level. The higher the altitude, the cooler the weather. So if you look at the mountain right there, of course you see snow on the mountain. Well, the higher you go up, you also know that the temperature is going to drop. So when the temperature drops, you're also going to see an issue there. Just ignore the phone. Distance from the sea. Coastal areas are cooler and wetter. Why are they cooler and wetter? Because they're feeding off of the land and the water that's moving from the water cycle and the sea breeze and the land breeze. You're having that much way more experience. If I were to go to the beach, the sand, of course, is hot, but I'm not usually so extremely hot at the beach because I got that breeze coming in. So if I'm closer to the coast, it's picking up that water, and it is cooling it down. It also can bring more rain. So we can also see that aspect too. Ocean currents and prevailing winds can increase and reduce temperatures based on where they come from. So if you look here, look at the currents of the ocean, and we talked about this earlier because this is the prevailing right here. This line right here is the prevailing westerlies. And right here, these two segments are the trade winds. And these are the prevailing westerlies. And these are the easterlies, polar easterlies. So right here is still the prevailing westerlies. But you see how this temperature right here, oops, let me go back. See how this temperature here, because the trade winds are moving this direction, or the prevailing westerlies are moving in this direction. That's what's causing that rotation and flow. So we'll talk a little bit more in depth next week on that. This will come into place when we talk about biomes, where we are really in the temperate zone. We are in the temperate forest, and you can see that we're in that blue, that green. It's just basically everybody in this little green experiences the same temperatures for the most part. Everyone who's in this dark, this neon blue experiences those temperatures. Now you'll notice that these blues, for the most part, stay in the exact same area. The green, for the most part, are in the exact same. If you go to the polar, look at the polar. They're at the very top of the climate and the very bottom. Those don't change too much. Once again, you can change a little bit based on your rotation and your revolution. That's why you notice that there is some red right here. But if you look over here, we're close to it, and you're like, why are they a little bit more hot? This map doesn't do it justice of exactly how close they are to. So don't stress. Okay, establishing climate. So when we're collecting data, we figure out the region's climate. We record the most daily temperatures ranges for amounts for about 30 years. So look at Salem, Oregon. Okay. You'll notice that they have the low is the dark blue, the high is the red. Okay. It looks like to be about a year's worth. It says about 30 years, but this is January to December. So you'll notice that its driest months are in the summer. Or however, if you look at South Carolina, they are almost opposite of Oregon. They get a lot more precipitation in the summer months. Well, Oregon doesn't experience the hurricanes that South Carolina gets. So they're in the subtropic zone, so they're getting it. Now, Nashville's kind of almost even the whole way around. They do have a few spikes in May and in November, December. They have them depending on where exactly they're at. Nashville is close enough to the mountains. So when we start talking about the mountain range, and we talked about the rain shadow effect, Nashville has a rain shadow effect. They are right before you get to the mountains, the Appalachian Mountains. So you'll notice that they might get a little bit more rain because in the mountains they might not get as much because it's being blocked. Look at Wyoming. Look at how dry Wyoming is in August. Very, very low. Where Nebraska is pretty much, you can see the incline and the decline. It's pretty decent. Idaho doesn't get a lot. Oregon really doesn't get a lot. However, look here. This is Salem, Oregon, and this is Madras, Oregon. So, totally different, same state. They're getting this from the coast. This is a little bit more inland. So, think about it. They get more rain on the coast than they do inland. So, that's just a cute little picture here. You'll take a minute and draw a Venn diagram talking about weather and climate and what they have in common. And if you will pause me and give them about 8 to 10 minutes to write down the difference between weather and climate and fill out their Venn diagram. Now that you've unpaused me, we're going to talk about the difference between weather and climate and what we have in each place. You might not have the exact same words that I have for weather. You might not have the exact same words I have for climate. If you don't have it, please make sure you put it in your notebook though. It could be very similar, then keep going for it. If it's not similar, make sure you add it. Weather is affected by temperature, humidity, wind, and air pressure, which we wrote down our notes earlier. It's measured over a short period of time, or we know that climate over here is measured over a long period of time. Weather is a day-to-day state of the atmosphere, where this is over climate is over a span of so many years. Weather is reported as a forecast, where climate is reported as averages. These are averages. These are averages for that time frame. Weather looks at it from a day or a week's perspective, where climate looks over it as a 30-year period. It could be 10-year period. It could be a 5-year period, especially with the climate change that's happening right now. That's, you're going to see it. Climate also is affected by the Earth's tilt, the altitude, the distance from the sea, the ocean currents, and the prevailing winds. So these are all important, and I'm sure you probably have long period of time, short period of time, day to day, long period, but you probably forgot in climate to write the Earth's tilt, the altitude, the distance from the sea, ocean currents, prevailing winds. You probably forgot to put that in there. So please make sure you have. What they have in common is they both look at temperature, they both look at precipitation, they both look at humidity, they both look at wind speed, and they both look at wind direction. So if you'll take a minute and write those in your middle. So I'm going to stop our video now, but if you need her to pause it so that you can make sure that you have it recorded, she will definitely pause it for you. And in the next video, we'll pick up on our next lesson. Thank you.